Let's see how to define internal and external fixity in the edges of shells in CYPE 3D. To do this, we open the Shells menu at the top of the interface. First, we use the Internal Fixity option to edit the internal fixity of a group of edges. Internal fixities define how the edges of the shells are connected to other adjacent elements present in the model, such as bars or other shells. To do this, we select the edges we wish to edit with the left mouse button or use the crossing method, and then we right-click the mouse. In the pop-up window, we define whether the internal fixity is free, fixed, or pinned, and we click Accept. In the model view, the program represents each fixity differently. The internal fixity defined in this way affects the internal nodes of the edge that is generated by the discretization of the shells. To change the internal fixity at the end nodes of the edge, we open the Node menu and click on Internal Fixity. Now let's see how to edit the external fixity of a group of edges. To do this, we open the Shells menu again and click on External Fixity. In the same way, we select the edges we wish to edit with the left mouse button or use the crossing method, and then right-click to confirm our selection. In the pop-up window, we can select the type of external fixity. External fixities define the global coercions of the selected edges. They restrict the displacement or rotation of the edge nodes and correspond to the supports on the ground and on other elements external to the model. By default, the edges of a newly inserted shell will be defined as free, meaning they will not have any external fixity. The other options allow us to define the external fixity on the edge. We use generic to manually define the restrictions for displacements and rotations in the three directions of the space. The displacements can be independent, in which case we must specify the behavior of the displacements in the three axes, dx, dy, and dz. When a displacement is free, it will not be coerced in a certain direction. If it is fixed, the displacement will be coerced and will have a fixed value. By default, this value is null, except if we use the Prescribed Displacements option from the Load menu, in which case it will take the value prescribed there. If we select Elastic, the program will assume an elastic support in that direction. On the right, we type in the elastic constant of the support in the indicated units. If the displacements are defined over a straight line, the nodes of the edge can only be displaced in the direction of the direction vector defined by the x, y, and z components entered on the right. In the directions perpendicular to this straight line, we can specify whether the support is fixed or elastic. If the displacements are defined over a plane, the nodes of the edge can only be displaced in the plane perpendicular to the vector defined by the entered x, y, and z components. In the same way, in the direction perpendicular to the plane, we specify whether the support is fixed or elastic. In the Rx, Ry, and Rz rotations, we select free if the rotation is not coerced in the indicated direction, fixed if the rotation is coerced and has a fixed and null value, or elastic if the coercion to the rotation is elastic, in which case we must type in the constant that regulates the rotational stiffness of the support. The remaining options in the External Fixity panel correspond to predefined external fixities that simplify data entry to speed up the process. Among the most useful are the Fixity option, which allows us to prevent displacements and rotations in the three directions of the space, and the Pinned Connection option, which only prevents displacements but still allows rotations. The options on the right side of the panel allow us to define free displacements over a straight line in the x, y, or z directions, or free displacements over a plane, the plane being parallel to axes xy, xz, or yz. The options in the first row also coerce rotations. Those in the second row keep rotations without coercion. In all these cases, the components of the direction vector of the line or of the vector perpendicular to the plane are already defined. The user is limited to indicating whether the displacement or rotation in each of the directions shown is fixed or elastic. Finally, we can define a free displacement over any straight line, or a free displacement over any plane, with coercing rotations or without coercing rotations. In this case, it is the user who enters the components of the direction vector. Lastly, we click Accept. The defined external fixity affects the internal nodes of the edge that are generated by the discretization of the shells and the end nodes of the edge in case no external fixity has been defined for these nodes. If edges with different external fixity conditions coincide in a node, none of them will be applied and the node will not be globally coerced. The program displays a warning on conflicting nodes after opening the analysis menu and selecting the Show Hide Incidents option.